In example 2, we are asked to find parametric equations for the portion of a parabola y equals x squared that starts at 0, 0 and ends at 2, 4. So let's draw this to get an idea of what we are even trying to parameterize. So I have my xy plane, and we are starting at 0, 0, and then we are ending at 2 and 1, 2, 3, 4 right up here. So we want to end at 2, 4. And we are describing a portion of a parabola that moves between those 2 points. So the parabola of y equals x squared. That looks somewhat like this. How do I describe that with a parametric curve? So how do I describe this as x equals some function of t and y equals some function of t? Well, I can just choose x to be equal to t because I'm moving along this parabola going this way, and so t increases all the way from 0 to 2. So I can just say let x be equal to t, where 0 is less or equal to t is less or equal to 2. So that definitely does the right thing to x. And then how do I find y? Well, y is equal to x squared. But if I let x be equal to t, then x squared is equal to t squared. And so by saying let y be equal to t squared, I am describing every point on this parabola. I can take any point and it will have input x, which I said is t, and it will have output y, which is t squared. And if I let t go from 0 to 2, I'm going to describe I'm describing every point on this parabola this way. So I can express it in parametric equations saying x equals t, y equals t squared, or in vector notation, I would get r of t is equal to ti plus t squared j, again, where t goes from 0 to 2.